Welcome friends for the lecture on gear trains. Gear trains means if there is more than two gears, then we call it as a gear trains. Combination of more gears when they made to mesh each other to transmit power from one shaft to another shaft. See, if there are only two gears, then we call it as a gear pair. Generally, these gear trains we use for this two purposes. One, if the distance between the two shafts is slightly bigger, that means if you want to accommodate that distance and you want to use only two gear, definitely the size of the gear will be bigger. But if you don't want the bigger size of the gear, then always we can use the intermediate gears in between the two and we can achieve the velocity ratio whatever we required. So if we add the intermediate gear, then that will become a gear train. And another purpose is sometimes we are using this gear train for changing the direction of rotation of the gear. See, if you are using the two gears, one is the driver and another one is driven, and suppose the driver is rotating in the clockwise direction, driven will rotate in the anti-clockwise direction, right? But we want the direction of rotation is clockwise only at the driven shaft. Then in that case, if you add one more gear, then definitely you will get the direction of the driven gear, it is in the clockwise direction, right? We'll say that. Now, there are mainly four types of the gear train. The first one is the simple gear train, second the compound gear train, third reverted gear train, and the fourth epicyclic gear train. We'll see this one by one. What do you mean by the simple gear train? When one gear meshes with the another, that means the second gear will meshes with the third gear will meshes with the fourth, and all are mounted on a separate shaft, then that gear train is called the simple gear train. Now just consider, suppose only two gears, one gear it is meshes with the another one, then the speed ratio for that gear train, it is N1 divided by N2. That means the speed of the driver divided by the speed of the driven, that is equal to the T2 by T1. That means the number of teeth on the driven divided by the number of teeth on the driver. Now, if you see the second case, here there are three gears, driver, one intermediate gear and the driven one. And all these gears are mounted on a separate shaft. That's what is a simple gear train. Now if you see the velocity ratio for this, N1 by N2, it is equal to T2 by T1. Then if you consider the second and third gear, then N2 by N3, because now this N2 will become driver for the third, right? So N2 by N3, it is equal to T3 by T1. Now if you take a product of this two, N1 by N2 into N2 by N3, it is equal to T2 by T1 into T3 by T2. Now N2 will get cancelled, so here it is N1 by N3, it is equal to T2 will also get cancelled, so T3 by T1. So that means the speed ratio for the simple gear train is the speed of the driver divided by the speed of the driven, that is equal to the number of teeth on the driven divided by the number of teeth on the driver, right? So idler gear will only change the direction of rotation. It has no effect on the gear ratio. Now the second one is the compound gear train. When there are more than one gear mounted on a single shaft, that is called the compound gear train. Now you can see here in this diagram, the gear 1 is mounted on a shaft 1 A. Now gear 2 and 3, if you see this, gear 2 and 3 it is mounted on a shaft B. Gear 4 and 5 it is mounted on a shaft C, and 6 it is mounted on a shaft D. That means the gear 2, 3, this is the compound gear. Gear 4, 5, this is also the compound gear, right? Now I'll find out the speed ratio for this. N1 by N2, that is equal to T2 by T1, as the gear number 1 it is meshes with the gear 2. Then the gear number 3 it is meshes with the gear 4. Then N3 by N4 it is equal to T4 by T3. Gear number 5 it is meshes with 6. So N5 by N6 it is equal to T6 by T5. Now if we take a product of all these three, then n1 by n2 into n3 by n4 into n5 by n6, that is equal to t2 by t1 into t4 by t3 into t6 by t5. Now, if you see here, this gear number 2 and gear number 3, it is mounted on a shaft B, same shaft. The shaft will rotate at same speed. That means n2 it is equal to n3. And the gear 4 and 5, it is mounted on again another shaft, that is C. That speed is same. So n4 it is equal to n5, means n2 if it is equal to n3, then n2 n3 will get cancelled. So n1 by n4. Now n4 and n5, that is also same. So n4 n5 will get cancelled. So what will remain there? n1 by n6, that is equal to t2 by t1 into t4 by t3 into t6 by t5. Now if you see the numerator values, then t2, t4 and t6, all these are the number of teeths on the driven gear, right? And divided by, that means in the numerator, denominator, you can see t1, t3 and t5. These are the number of teeths on driver. So therefore the speed ratio, the speed of the first driver divided by the speed of the last driven, that is equal to the product of number of teeth on the driven divided by the product of number of teeth on the driver, right? Then the third case, when the axis of the first driver and the last driven are coaxial, then the gear train is called a reverted gear train. In this diagram you can see the gear number 1, it is meshes with the gear number 2. 2 and 3, these are the compound gears because it is mounted on the same shaft. And then this gear number 4, it is meshes with the gear 3, but the shaft it is different than the gear 1, but it is the coaxial. That means it is in the same line, right? So you can see the distance between the two axes, it is same. So therefore R1 P circle radius of the gear 1 plus P circle radius of the gear 2, this is equal to the P circle radius of the gear 3 plus the P circle radius of the gear 4. That means R1 plus R2, it is equal to R3 plus R4. Now, you know R1 it is equal to, R it is equal to generally M into T divided by 2, right? So R1 it is equal to M T1 divided by 2. Similarly R2 it is equal to M T2 divided by 2, M T3 divided by 3, and R4 it is equal to M T4 divided by 2. If you substitute that value in the R1, R2, R3, R4, then M divided by 2, it is common and it will get cancelled. So T1 plus T2, it is equal to T3 plus T4. And the velocity ratio for this, again N2 and N3, it is on the same shaft. So speed of the N2 and N3 will remain same. So N1 by N2 into N3 by N4. So N2 N3 will get cancelled. So we'll get N1 by N4, that is equal to T2 by T1 into T4 by T3, right? This is the velocity ratio for the gear train. And the fourth one, that is the epicyclic gear train. Now here you can see this gear A, it is pivoted and it is fixed. Then the arm C, and then the gear B, it is mounted at the, it is pivoted at point O2 and it is meshed with the gear A. Now when the arm rotates, definitely the gear B will also rotate. Now what is the difference between the previous 3 gear trains and this epicyclic gear train? In the previous 3 gear trains, you must have seen the axis of the shaft on which the gears are mounted, it is fixed. Whereas here in the epicyclic gear train, the axis, position of the axis is varies. You can see here, if your gear A is fixed and the arm C rotates, then definitely this gear B will also rotate about B. At the same time, this axis which is passing through O2, that will also rotate. That means the position of that gear, axis of the shaft of the gear B, that varies. So epi means it is upon, and the cyclic means the around. So this gear B will rotate above around the gear A with the help of this arm C. Now this type of problem you can solve either by the tabular method or by the algebraic method. But the tabular method is the easiest method, and so we'll consider here it is the tabular method only. In tabular method, always this table consists of main three columns. Step number 1, condition of the motion and the revolution of the elements. Under this revolution of the elements, we can again take the number of the columns, and that is depend on the number of the elements. Now here in this cyclic gear train, we can see arm C, gear A and gear B. Only 3 elements, and that's why we divided this revolution of elements into these 3 columns. So for step 1, always you consider, now you can see here, if I fix this arm C, then it will become a simple gear train, right? If the arm C is fixed and if I rotate the gear A, then gear B will rotate. If suppose gear A is rotating with 1 revolution, definitely you can calculate the number of revolution for the gear B, right, according to the number of teeth or according to the diameter, right? So that's why here in this table, when you start it, always consider the arm is fixed. Now if the arm is fixed and the gear A rotates in 1 revolution, so rotation of the arm, it is 0, gear A, it is 1 revolution, and now you have to find out the revolutions of the gear B. I will find out the revolution of the gear B. We know that Na divided by Nb, it is equal to Tb divided by Ta. Now can I write in the reverse fashion that Nb divided by Na, it is equal to Ta divided by Tb. Now Na is what? It is the revolutions of the gear A. We have taken the revolution of the gear A is 1. So Na it is equal to 1. So that means Nb it is equal to now Ta by Tb, right? Now if you see the revolution of the elements gear B, it is written minus. Now why it is minus? We have already considered, see, 1 revolution in anti-clockwise, and that we have taken positive. So generally for anti-clockwise revolutions we are taking positive here, and for the clockwise we are taking negative. Now when your gear A rotates in anti-clockwise direction, definitely the gear B will rotate in the clockwise direction, and so as the direction of rotation of the gear B it is clockwise, here we have written minus. Now once you write this row, then other rows remaining 2, 3 and 4, it is very simple. Now instead of 1 rotation for the gear A, you consider the x revolution. So again, see what if we have written here, arm fix, gear A rotates through x revolution. Now you have to multiply by this x to this row 1. So x into 0 is 0, that means arm revolution will be 0, gear A ka revolution x, and the revolution of the gear B, it is x into Ta minus Tb, negative, right? Now the third row, always add the plus y revolution in all the elements. Whatever the revolution you are getting in the second row, you add y in the third row. So y plus y plus y plus y. Now the total motion, it is plus y for arm C, gear A it is x plus y, and for the gear B it is y minus x Ta by Tb, right? Now this is the simple epicyclic gear train. Now we'll consider this for the compound epicyclic gear train. Now in compound epicyclic gear train, there must be the compound gear. Now sun and planet gear. Now see, we'll consider this annulus gear A, and around which all the gears will rotate. Now this annulus, it is the internal gear, right? This A, it is having the internal teeth. Now A, it is meshes with the gear B. Then gear B and C, these are the compound gears. You can see here in this left hand side sectional front view, here it is written compound gear, and that is B, it is meshes with A, annulus gear, and the C, it is mounted on the same shaft, and then the C, it is meshes with the gear D, right? And then there is a arm H, right? So here in this, now in this type of problem, either you can start from the inner gear or from the outermost gear. Now again here we'll consider the arm is fixed. Now, how many elements are there? The gear A, gear, compound gear B and C, and the gear D, and the arm H. Now see how to prepare this table. Again, step number, condition of motion and the revolution of elements. Now, how many elements are involved here? Arm, gear A, then don't consider B and C are separate because these are the compound gear which is mounted on a shaft. So consider single one, that is compound, BC, and the gear D. Now here, as I told you, always consider the arm fix. So therefore here it is written in the first. See, this first row is very important. If you are able to write it properly, then your whole numerical will be correct. Otherwise, it is very difficult to solve that. Now, in the first row, always you have to write arm fixed. And then, now whether you have to write this gear D or gear B or gear A, that is, for that I told you, you start either from the innermost gear or from the outermost gear. Now here, we are writing from the innermost one. So therefore, I have taken the gear D rotates through one complete revolution, right? So this D, it is the innermost gear, correct? So plus one revolution we have taken. Now the gear D, it is meshes with the gear C, correct? So how we can write TD divided by TC? Now whether it is negative or positive. Now if your gear D, we have taken the gear D rotates through plus one revolution, that is in the anticlockwise direction. We have taken the direction of rotation of D, it is anticlockwise. So C will rotate in the clockwise direction. So for clockwise it is negative. So therefore it is TD by TC, right? Number of teeth on the driver divided by the number of teeth on the driven, correct? Now gear A. After that, see, your seat is mounted on a shaft on which the gear B is mounted, and then gear B, it is meshed with A. So that means first the revolutions for the C, you have to write that is TD by TC, correct? Now here the C is rotating in clockwise direction, B will also rotate in clockwise direction. Now B, it is meshes with A, and that is internal gear. So for the internal gear, if the B is rotating in clockwise direction, A will also rotate in the clockwise direction, right? And therefore it is minus. Now the revolution for B, it is TD by TC, right? Now what is the revolution for A? The revolution for A, TD by TC multiply by TB by TA, right? So this way you have to write the total revolution of the gear A. Now the second condition, only you have to convert into the X revolution. Arm fix, gear A rotates through X revolution. So again you have to multiply by X throughout this. So X minus X TD by TC for compound gear and X TD by TC into TB by TA for the gear A. Then add Y revolution for the all element. So that means plus Y plus Y plus Y plus Y for all the elements, and then the total motion you will get plus Y, X plus Y, then Y minus X TD by TC and Y minus X TD by TC into TB by TA, right? Now we'll see one numerical here. Here it is given in an epicyclic gear train, the internal wheels A and B, these are the two internal wheels, and the compound wheel C and D rotate independently about the axis O. The wheel E and F rotates on pin fixed to the arm G. E gears with A, that means gear A, it is meshes with internal gear, gear E will meshes with the internal gear A, and the C and F gear with the B and the D. F gear, which is B, F gear is meshes with the B and the D. You can see in this diagram. All the wheels have the same module and the number of teeth are given here. TC it is equal to 28, TD 26, T equal to TF and that is 18. So he has asked to sketch the arrangement. The arrangement is this only, right? Whatever it is shown in the diagram, that means in this question he has not given this diagram. You have to sketch the diagram according to the given data. And then he has asked find the number of teeth on A and B. If the arm G makes 100 RPM clockwise and A is fixed, find the speed of the B. And the fourth he has asked if the arm G makes 100 RPM clockwise and wheel A makes 10 RPM counterclockwise, find the speed of the wheel B. Okay. Now, first you have to sketch this if it is not given, and then according to this sketch, now let TA it is the number of teeth on the wheel A and TB it is the number of teeth on the wheel B. If DA, DB, DC, DD, DE and DF are the pitch circle diameters of the wheel A, B, C, D, E, F respectively, then from the geometry of the figure we can write here, see this diameter of A, this is equal to the diameter of the C plus 2 times the diameter of the E, right? So you can see here it is written DA it is equal to DC plus 2 times DE and DB it is equal to, you can see here DB means, B means the inner one. Now DB means this DD plus 2 times DF, right? Now since the number of teeth are proportional to their pitch circle diameters for the same module, and therefore TA plus TC plus 2 times TE, and TC and TA is given to you, so just substitute the value, you will get a TA it is 64 and TB it is equal to TD plus 2 times TF, that you are getting 62, right? So this way first you can find out the number of teeth on the wheel A and B. Now then it is asked to calculate the speed of the B when the arm G makes 100 RPM clockwise and the wheel A is fixed. Now for this you have to prepare this table. Now first again, as I told you, step number, condition of motion and the revolution of the elements. Now here under this revolution of the elements you have to create a number of columns and that is equal to the number of elements. Now how many number of elements are there? The first arm, if you see this diagram, arm G, right? Then now either you can start from the outermost gear A or you can start from the innermost gear C. Now here we'll start from the outermost gear A. That's why here in the next column it is wheel A, right? Then this wheel A it is meshed with the wheel E, right? So next will be wheel E. Then this E it is meshed with the gear C. Here C and D are the compound gear, so don't consider separately. See, therefore see the next column it is the compound wheel C and D. Then the next one, now this C it is meshed with, sorry, C it is meshed with E, right? Now we got this C and D, these are the compound gear. So gear D it is meshed with the gear F. So then the next column will be wheel F, and that means the revolution for the wheel F, and then this F it is meshed with the B. So the last column will be wheel B. And here in this column, so if speed of the wheel B it is asked, so we should know the total revolutions of the wheel B, right? So in the last row and the last column, you will get this equation. Now, how to write this? See, first you have prepared this. Now the first case, arm fix, right? We have to fix the arm. And now we are starting from the outermost gear. So consider the wheel A rotates through one revolution, and that is in the anti-clockwise direction. Now when the wheel A rotates in anti-clockwise direction, now A, it is meshes with E internally, so E will also rotate in the anti-clockwise direction, right? And therefore the revolution of the wheel E, it is TA, number of teeth on the driver, divided by the number of teeth on the driven, TE, right? Now then E, it is meshes with which gear? C. Now these are the external gears. So you know that the E now it is rotating in anti-clockwise direction. So C will rotate in the clockwise direction, right? So negative. Now revolutions for this is, first the revolution for E, it is TA by TE, and the revolution for C, it is multiply by TE by TC, right? So therefore now TE will get cancelled, so minus TA by TC, that is the revolution for the gear C and D. Then your D, it is meshes with F. Now you know the revolution of the D, it is minus TD, revolution of the D, it is minus TA by TC. Now when the gear D, it is meshes with F. Now D, it was rotating in clockwise direction. Now your F definitely will rotate in the anti-clockwise direction. So the motion for the F, it is anti-clockwise, that means plus. Now how to write that revolution? TA by TC into TD by TF, right? So this is the motion for the wheel F. Now wheel F, it is meshes with wheel B. As your wheel F, it is rotating in anti-clockwise direction, wheel F, it is meshes with wheel B internally, that means B will also rotate in the anti-clockwise direction, right? So again it is positive. So the motion of the wheel F, TA by TC into TD by TF, right? And the wheel B, this multiply by TF by TB. Now TF and TF will get cancelled. Here we will get the motion of the wheel B, it is TA by TC into TD by TB. When you are getting this motion, when the arm is fixed and wheel A rotates through one revolution. Now in the next row, you consider the arm fix and wheel A makes X revolution. So throughout this you have to multiply by X. So 1 will become X. This TA by T will become X into TA by T. This minus TA by TC will become minus X TA by TC. This for wheel F, this will become X multiplied by TA by TC into TD by TF, and for wheel B, X multiplied by TA by TC into TD by TB. Now third row, we know that you have to add Y revolution, so plus Y, and from this you will get the total motion. For arm it is Y, for wheel A X plus Y, for wheel E it is Y plus X TA by TE, for compound gear it is Y minus X TA by TC, for wheel F it is Y plus X TA by TC into TD by TF, and for the wheel B it is Y plus X TA by TC into TD by TB, right? This way you will get first the table, and now once you get the table you can answer anything. Now what is asked here? Here it is asked to calculate the speed of the wheel B when arm G makes 100 RPM. Now arm G makes 100 rpm, that means the total motion of the arm is y, so y it is equal to 100, right? And the wheel A is fixed. So wheel A is fixed, that means the motion total revolution of the wheel A x plus y it is equal to 0. So you can start from here, since the arm G makes 100 rpm. Now arm G makes 100 rpm in clockwise direction, so y it is equal to minus 100, right? So y it is equal to minus 100. Also A is fixed, so x plus y it is equal to 0. So x it is equal to minus y, so x equal to 100 mm. Now we want to calculate the speed of the wheel B. So speed of the wheel B, y plus x Ta by Tc into Td by Tb. So y plus x Ta by Tc into Td by Tb. Just substitute the value of x and y. Y it is minus 100, x it is 100, Ta 64, Tc 28, Td 26, Tb 62. Substitute the value, you will get the speed of the wheel B, it is negative. That means wheel B, it is rotating in the clockwise direction, right? 4.2 rpm. Then in the fourth, he has asked to calculate the speed of the wheel B, but in different condition, when arm G makes 100 rpm clockwise and wheel A makes 10 rpm counterclockwise. Now your condition will change. Y it is equal to minus 100, that will remain same, but wheel revolution of the wheel A, it is x plus y. So x plus y in anti-clockwise, that means x plus y it is equal to 10, right? So x it is equal to 10 minus y, y is minus 100, so x will become 110. Now again for the speed B, your equation is same, only the value of x and y will be different. So y it is minus 100 and x it is 110. You substitute, you will get the speed of the wheel B, it is plus 5.4. That means now wheel B will rotate in the anti-clockwise direction, right? So the speed of the wheel B, it is 5.4 rpm in the anti-clockwise direction. Okay, dear friends, now take care and goodbye.